Today we're resuming with question 8 from the Financial Mathematics Theory booklet. So for question 8, the nth term of an arithmetic series or sequence is 7n plus 4n. Write down the first 4 terms and hence find the values of a and d. So we're going to substitute in n as 1, 2, 3, and 4 into this formula. So that t1 is 7 plus 4 times 1, which is 11. 7 plus 4 times 2 is going to be 15. And then if you sub in 3, it would be 19. Sub in 4, and that would be 23. A would equal to 11, and then D is equal to 4 because it's going up by 4. Then, for question B, find the sum and difference of the 50th and 25th terms. So T50 is 7 plus 4 times 50. Okay, and that would equal to 207. T25 is 7 plus 4 times 25. Okay, and then that will be 107. Now we're being asked to add them, so find the sum of and find the difference of these two numbers. So the sum of these two numbers, so T50 plus T25 would equal to the addition of these two numbers, which is 314. Whereas if you subtract them, that would be 100. Okay? All right. Prove that 5t1 for question C plus 4t2 equals to t27. Okay, so 5 times the first term. Our first term is a, which is 11. Okay, t2 we don't know, but we can directly substitute that in. So we can say LHS, first of all, is 5 times 11. So that's the a value there. Okay, then plus by 4 times the second term. So if I substitute in 2 in here, okay, I'll have 7 plus 4 times 2. So that's 55 plus 4 times 7 plus 8, which is 15. And that's 55 plus 60, which is 115. Okay. Whereas on the right hand side, it's supposedly equal to the 27th term. So let's sub in n as 27. So 7 plus 4 times 27. Just check that in my calculator. And it does give you 115. Okay, which term of the sequence is 115? So this part here is Tn. We set that as the term that we want, and that will allow us to find out what term it is, what position it is. So 815 would equal to 7 plus 4n. Subtracting 7 to both sides will give us 808 equals 4n. And dividing both sides by 4, n would equal to 202. Okay? So that means that 815 is the 202nd term. Find the last term for E less than 1,000 and first term greater than 1,000. So if we look at our formula is 7 plus 4n. You want that term to be less than 1,000. So subtracting 7 to both sides gives you 4n less than 993. If we divide both sides by 4, n is less than 248.25. And since n is a number that's less than this and must be an integer for the position, we can say n is the first number less than that, which is 248. So it's the 248th term. And we got to find that term. So we got to write T248 for the 248th term is 7 plus 4 times 248. So by doing that, I would get the number 999. Okay. Now, to get the first term greater than 1,000 is easy. You don't actually have to do this again and make it bigger than 1,000. You can just get this number here and plus 4 to it. Because the next number, which is the 249th term, should be the previous number, since this is an arithmetic progression, added by the common difference of 4, and this will be 1003, which is the first number, greater than 1000. F. Find which terms are between 200 and 300 and how many of them there are. Okay, so for this particular question, we're going to use our formula, 7 plus 4n. We'll make this greater than 200. Okay, so between 200 and 300 means bigger than 200, okay? It cannot be 200. So we have to exclude 200 by not running equal sign there. And we put the 7 to our side, and that will give us 193. Oops. And 193 divided by 4 would be 48.25. So therefore, n is the first number bigger than that, which is 49. Okay, so that's the 49th term, right? And if we do the other way, where we get the first number that is less than 300, subtract 7 to both sides, so that will give you 293. 293 divided by 4 gives you 73.25. Okay, and so therefore n would equal to 73, right? So how many numbers are there that is inclusive of this number? So the 49th term and the 73rd term. Okay, what you've got to do here is you've got to subtract the 2 and add it up by 1. Okay, that's the secret. So the number of terms, if you're including both those beginning and last terms, is you get the 73rd term, okay, minus 49th term, all right, and then you plus that 1 at the end, and that will give you 25 terms, okay? A simple way of thinking that is what happens if there's the first term and the second term, right? Like how many numbers are there between like 1 to 2? Well, you're going to get 2 minus 1, and that's 1, and you can't say there's only one term because there's 2 of them. So you plus 1 to it, and that will equal to 2 terms. Okay, that's the way you think about it. Question 9. Let Tn be the sequence of positive multiples of 6. Find the first term of the sequence greater than 400. Okay, so if they are multiples of 6, what this means is you're going to have Tn equals to 6n, where every time you substitute in n as 1, 2, 3, 4, 5, producing these numbers, it will be multiples of 6. Okay, find the first term of the sequence greater than 400. All right, so we're going to set 6n greater than 400, and we simply divide both sides by 6. So n is greater than 66.6 recurring, and the first whole number for n greater than that would be n equals to 67. So if we're going to find out T67, okay, T67 would equal to 6 times 67. So 6 times 67 is the number 402. Question B. Find the last term of the sequence less than 640. So 6n would be less than 640. So by dividing 640 by 6, we get n is less than 106.6 recurring. So therefore n is 106. So the 106th term is going to be 6 times of 106 by substituting it back into the formula, and that gives you 636, which is the first term that is less than 640. Part C. Hence find the number of positive multiples of 6 between 400 and 600. Okay, we do the same thing as before. So 6n has to be greater than 400, but also 6n has to be less than 600. So if you divide both sides by 6 for the first one, oh, actually we did that already, didn't we? Oh, no, we didn't. We did this one. So 6n is greater than 400. That gives you this. So we can copy that down. So n is the 67th term. Okay. But if we do the other way, 6n is less than 600. So n is less than 100. Right? And the thing is, n would equal to 99. Right? I'm thinking this is meant to be 640. I think there's a mistake here, but it doesn't matter. Let's just continue on with this for now. Okay, I'm just going to circle that answer. But anyway, if I get 99 minus 67 plus 1, so the number of terms, would equal to 99 minus 67 plus 1, you will get 33 terms. Okay? Whereas if you treated this as 640 and continue on with what you got in part A, part B, because it matches the 400 and 640, then you would get 106 minus 67 plus 1, which does give you that answer of 40 there. Okay, so that's my mistake. Okay, so I'll change that in the future. All right. So sometimes we might encounter simultaneous equations if we're given information about a particular term, such as the value of its term and also the position of its term. So if you have a look at the example 1, the 11th term of an AP is 37, the 20th term is 64. So we say T11, okay, well actually we should write T of n equals to a plus n minus 1d first, okay, since we haven't read that this last lesson. And we don't know what's a, and we don't know what's d. We only know what is n for now, as well as Tn, which is the term. So T11 equals to a plus 11 minus 1d, and that's supposed to equal to the number 37 as the term. So simplifying that down, we get a plus 10d equals to 37. We'll stop there. Okay? Then what we can do is write down T20 with the 20th term. Okay, that's 64. And we represent that using our term formula. So a plus n, which is 20, minus 1d is 64. So a plus 19d is 64. And then we'll call this equation 1 and 2. So now we have two equations that would solve simultaneously for a and d. We would now do equation 1 minus, equation 2 minus equation 1. So we get the a here minus that a there, and they'll cancel. 19d minus 10d is 9d. And then 64 subtracted by 37 gives us the number 27. So now d would equal to 3. Okay? But once we get d equals 3, remember we need to find both a and d. So we found d, we need to find a now. So we'll substitute this back into equation 1. So we'll say sub into equation 1 for now. And so a plus 10 times 3 would equal to 37. That's a plus 30 being 37. So subtracting 30 over gives us the number 7. So there's our two answers. D equals 3 and a equals 7. All right, moving on to exercise 3.3. Okay, this is basically the same thing, right? So we'll do this together. So T of n is a plus n minus 1d. T6 apparently is 14. So a plus 6 minus 1d is 14. So a plus 5d is 14. Now T23 is a plus 23 minus 1d. and that's equal to 48. So a plus 22d is 48. We'll call this equation 1 and 2. So I usually get the equation with the larger value of d, or coefficient of d, to be subtracted with the other equation. So the larger one is this one. So we're going to get equation 2 minus equation 1, where we now get the a's cancelling each other when we subtract them. But when we get the these subtracted by each other, 22d minus 5d gives you 17d, whereas 48 minus 14 gives you the number 32. Oh no, 34, sorry. Dividing both sides by 17 does give you a result of 2 very nicely. Then we've got to substitute this back into any one of those equations. Okay, I find equation 1 better because it has lower coefficients. So I would say sub into equation 1. A plus 5 times 2 equals 14. So that means a plus 10 equals 14. And subtracting 10 over will give you a is equal to 4. Okay? And then there's your homework, which you do later. Moving on. All right. So we've now learned out that Tn equals a plus n minus 1d, and that's our general term formula, which generates any kind of term in a series. But now what we're going to do is we're going to sum arithmetic series. So if we have, t1, t2, t3, all up to tn, what's the sum of this? What's the formula that would generate this, right? So, so we usually write Sn, so S subscript n for the sum of. This means sum of one term. Sum of two terms means t1 plus t2. Sum of three terms means term 1 plus term 2 plus term 3, and then so on. Okay, so you know that this is going to be Sn for n terms, all added together. So the trick is doing this. Let's have a look at this example. Consider the following series, and let's try and find an easy way to sum these numbers. So we've got 1 plus 2 plus 3 plus 4 plus 5, all the way up to 1,000, and it all goes up by a difference of 1. What is the first and last term and the sum of those two things? So if we sum these two numbers, 1 and 1,000, that gives you 1,001, obviously. Now what if we do the sum of the second and second last term? So we get the 2 and the 900. That will be also 1,001. Third and the third last term, that would also be 1,001. Now, how many pairs are there that sum up to above number in the series? Well, think about it. Every single time we get 1,001, we're actually picking two numbers. So this 1,001, two numbers. Okay, this 1,001, two numbers. So how many pairs of numbers can you get out of 1,000 numbers? That would be 1,000 divided by 2, which is 500 pairs. So we say it is 500. Now, this is generated from 1,000 divided by 2. I'm going to write that down, okay, because we do need that in a second. So 1,000 divided by 2 gives you 500, so there's 500 pairs. And now we've got to find a formula that would generate all the numbers. So if there are 500 pairs, so that's 1 pair, 2 pairs, 3 pairs, and so forth, right? And there's 500 of them. We just have to do 500 times of this sum, which is 1,001, because they're always the same, okay? It's always going to be 1,001. So why don't we just do 500 of them, okay, which is the same thing as 1,000 over 2, okay, over there, times by 1,001. Okay, oops. All right, and there's our formula. Okay, this is actually our formula that we're going to now put together into a general term. So let's have a look now in general. If we have Sn being T1 plus T2 all the way up to Tn, so the nth term, and you know that this is A, whereas this one here is just that value plus D, right? And T3 would be T2 plus D, so it's going to be A plus 2D and A plus 3D and so on. Our last term was Tn, which was A plus n minus 1D. That's our formula. So, remember how we said that it's just the number of terms, okay, divided by 2 times by the value of the first and last term. So we're making the last term here equal to L. Okay, that's what it's saying here. Okay, so now it changes to this. So the sum of the first and last number, A and L, is going to be A plus L. The number of pairs that would sum up to this number, okay, so if there's n terms here, then half of those, okay, half of n will give you n over 2, and that will tell you how many pairs of, the first and last, second and second last, and so forth are there. Now, if you multiply your two numbers, you get n over 2, A plus L, and that is your formula for Sn. So Sn, the sum of n terms, is given by n over 2 times the first and the last term, right? That will give you the sum of all the numbers, okay, which is an easy formula. Now, there's another way to actually do this. So given that we know now that the sum of the arithmetic series is this, okay, and we know that the last term is a plus n minus 1d, we can actually just replace that L back by a plus n minus 1d. Okay, so if I replace that by a plus n minus 1d, I will get this part. Okay, and what do you know? In this square bracket, we have two a's which can add together, and that's 2a. And plus n minus 1d times by the n over 2 on the outside gives you a new formula, which is all in terms of a and d, whereas this one was in terms of a and l, the first and the last term. So we actually use both of these equations, okay? So this one and this new one here, okay? Depending on the situation and what the question actually gives us, right? So I'm not gonna go ahead and do this. You can have a look at that yourself if you want to know the other proof, right? But that's your sum formula. Okay, so for this particular page, exercise 3.4, find the sum to 8 terms of the series 3 plus 10 plus 17 plus so on. So let me just write down the formulas so that you know which one to use, and I'll repeat them every single time. So you got to firstly ask yourself, what can you find from these values here? Do you have the last term? Do you have the last term? No. So do you have the first term, which is a, and the common difference, d, as well as the n value, 8? Yes, you do. Okay, you know that a is equal to 3 and d is equal to 7 by getting 10 minus 3. So we can substitute it into this formula. So S of 8, so the sum of 8 terms, will be 8 over 2 by replacing n by 8. We have 2a, which is 2 times 3, plus n minus 1d, which is 8 minus 1, times d, which is 7. Okay? So if I put that all in my calculator, I do get the number 220. So that sums up the first 8 numbers. Question 2. Find the sum of the first 20 terms of the arithmetic series with first term 17, common difference 4. So again, which formula do we use? We use this one. So the sum of the first 20 terms, so S20, is n, which is 20 over 2. 2a is 2 times the first term, so that's negative 17, plus n minus 1, which is the number of terms, 20 minus 1, d, which is 4, okay, and then putting all that in my calculator should give me the number 420, okay. Question 3, evaluate the sum of 3n minus 4, where 1 is substituted in all the way up to 19. So if we substitute in 1, we get 3 times 1 minus 4, and 3 times 1 minus 4 is negative 1. If we substitute in 2, we get 3 times 2 minus 4, that's 6 minus 4, which is 2. And you know what? Because of that 3n there, that means it goes up by 3. So the pattern is like that. In the last term, which is 3 times 19 minus 4, that's 57 minus 4, which is 53. Here we go. So it's asking us to sum up all these numbers here. Great. Okay. that's 19 terms, so we do S19 equals 19 over 2, 2 times the first term, which is -1, plus n minus 1d, which is 19 minus 1, and our d value, which is our common difference, is the number 3. It's positive 3. And then putting that on a calculator once more should give us 494. Okay, question 4. Find the sum of the first 17 terms of the arithmetic series, where the first term is 8 and the 17th term is 103. So this is a little different. We say the 17th term, T17, is this. Okay, so, well, if we want to find S of 17, okay, hold on. Let's ask ourselves, do we have the first and last term, or do we have the first term and the common difference? There is no sign of the common difference anywhere compared to like the last question where it says the common difference is this, or we could actually generate it. Okay, so here what we're going to do is we're going to use this formula. Okay, because the last term of the sum of 17 terms is the 17th term. Okay, so S17, or Sn I should say, let's write this down once. Sn is n over 2, a plus l, but S17 will be 17 over 2, then a, which is 8, plus by l, which is the last term, so that's 103, and the last term of the sum of 17 terms is the 17th term anyway. Okay, so 17 over 2 times by 8 plus 103 should give me 943.5. There we go. All right, question 5. Find 4 plus 7 plus 10 all the way up to 145. Okay, so see how in our formula skills, we do have the last term, right, of 145. We do have the first term of 4, but the problem is that we don't actually have how many terms there are. And so we're going to find that out, right? So even if we use this formula as well, we don't have the n value. So to find that out, you simply go to the last term, and this is represented by Tn, because we know that this is T1, T2, all the way up to Tn, right? So if Tn equals to A plus n minus 1d, where A is 4 and d is simply 7 minus 4, which is 3, then Tn, which is 145, should equal to A, which is 4, plus n minus 1d, which is, in this case, we don't know what that is, and then d is 3. So we subtract 4 to both sides, that's 141, and n minus 1 times 3 is next. If we divide both sides by 3, we get 47 equals to n minus 1, so therefore n equals to 48. So now t of 48 is that term. And also what that means is there's 48 terms altogether. So we can do S of 48, and we can simply use this formula here, okay? Because we do have the last term, the 48th term. And that will be 48 now over 2 brackets 4 plus 145, okay, that being last term, and that should equal to 3,576.